M. Victor Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to DTH channel, lecture 12 of Astronomy and Astrophysics. This lecture is about exoplanets. Earth-like planet, a search for Earth-like planet in the universe. Exoplanets are planets where life is possible. So I am going to discuss more elaborately about this exoplanet. I am going to organize this lecture in the following way: introduction, then habitable zone, ways to discover an exoplanet, and summary of the discussions we are going to have. Exoplanet is a planet beyond our solar system. We know many solar systems are there in the universe. In our Milky Way galaxy itself, innumerable solar systems are there. For a solar system, a star is required, then some planets should revolve around the star. That's the requirement for a solar system. In our solar system, Sun is the star, 8 planets are there. Like that, many planets beyond our solar systems are invented, discovered by the astronomer. They are all named as exoplanet. The Planet Hunting Space Telescope, NASA's Kepler Space Telescope, finds a hot, heavy world dubbed as Kepler 10b exoplanet. This Kepler 10 is a star in our galaxy. This Kepler 10 star is explored by Kepler's Space Telescope. Then Kepler 10b is a planet orbiting around Kepler 10 star, so that it is an exoplanet. In Milky Way galaxy alone, there are 3081 solar systems are there, explored solar system. Apart from this known solar system, many may be there. Astronomers and scientists are still exploring the existence of many solar systems. In Milky Way galaxy alone, if you take our universe, many galaxies are there. If each galaxy is account for this 3000 solar system, then you can think about billions of solar system in our universe. Then coming to the confirmed exoplanet in our Milky Way galaxy, there are 4158 exoplanets are identified, named by the astronomers in Earth. 1000 more candidate planets, exoplanets found by Kepler Space Telescope await confirmation. International Astronomical Union should confirm they are all exoplanets. They have certain definition to confirm an exoplanet. So if a planet found by an astronomer fulfills that definition, then it can be approved as an exoplanet by the International Astronomical Union. Since the first confirmation of an exoplanet orbiting a sun-like star in 1995, many exoplanets are discovered. A recent statistical estimate places on average at least one planet around every star in the galaxy. There are many stars are there. If you think about one planet around every star, then it will go millions of trillions of exoplanets are possible in our galaxy alone. So That means there is something on the order of 1 trillion planets in our galaxy alone, many of them in the Earth size range. The exoplanet discovered in 1995 was a hot, star-hugging gas giant believed to be about half the size of a Jupiter. This exoplanet tugged so hard, bound so hard on its parent star as it raced around in a 4-day orbit that the star's wobbling was obvious to earthly telescopes. This is exoplanet named 51 Pegasi b, also called Dimidium. This was the first exoplanet discovered orbiting a star like our sun. This is a star. This star looks like our sun. This is that 51 Pegasi b, which is also called Dimidium. Now coming to the habitable zone in other solar system. In our solar system, the region in which our Earth exists is the habitable zone. Habitable zone in the sense the temperature should not be too high and should not be too low. So that's the meaning of habitable zone. If the temperature is too high, then living organism cannot exist in that region, in that zone. If it is too cold, in the same case, the living organism cannot exist. And the size of that zone or the planets existing in that zone should roughly be equal to the size of the Earth. That means 2 times the size of the Earth or 1.5 times the size of the Earth. Like that, the planet to be explored, to be approved as habitable planet should have this character. So first scientists are exploring the habitable zone in Earth, in our galaxy and in our universe. Once that habitable zone is identified, then the planet in that habitable zone will be explored more deeply. That means atmosphere of the planet and content or elements present in the atmosphere of the planet and the size of the planet, temperature of the planet, all these things will be explored. Then finally they will conclude, life is possible in that planet. So this will be the prediction they will be giving once they find a habitable zone and a habitable planet. People are still no habitable zone is found, but people are continuing their exploration to find the habitable zone. These are all the telescopes in use in space to find the habitable zone and to explore the exoplanets. This is the Spitzer, Kepler's Space Telescope, Hubble Space Telescope. These are all major contributors to the images, heaven images, or the images of the universe, galaxy we are seeing today in our day-to-day life. Major contributors in space exploration. These telescopes contributes a lot for the discovery of exoplanet. As I told earlier in the introduction, there are around 4,000 exoplanets are approved and still more are in line for approval. So all these things are possible because of these telescopes. Coming to discover an exoplanet. Scientists adapt 5 ways to discover an exoplanet. The first method is radial velocity, or watching for wobble of the star around which the planet is rotating, revolving. Then transit method, watch for shadows of the planet or watch for the dimming of light emanated from the star. So that's the transit method. Then direct imaging, taking the pictures of the exoplanet. This is a difficult one because the star around which the planet is rotating will be disturbed by the light emanate or coming out from the star. from our sun itself huge amount of light comes out. Like that, the star around which the exoplanets are rotating also will give out huge amount of light. By stopping those huge amount of light, the picture of the planet has to be taken, should be taken. So direct imaging is a bit difficult technique. People are exploring, astronomers are still exploring ways to directly photograph the image of the planet. Then gravitational micro lensing. Here gravity concept is used. Then when light travels in a gravity, the bending of light will take place. That is the concept of gravity lensing. This concept is also used by the astronomers to identify, to discover an exoplanet. Then astrometry, minuscule movement of the star. All these 5 techniques are used elaborately by the astronomers to discover an exoplanet. Coming to the radial velocity. In this radial velocity concept, watching for wobble of the star is used. That means when exoplanet is rotating around the star, this is the star, this is that exoplanet, it rotates, gravitational force will be there between the star and the exoplanet. This exoplanet is very small. If suppose this exoplanet size is very small compared to size of this star, then gravitational pull by this star will be large than the gravitational pull by this exoplanet. Though this gravitational pull is small, the star's orbit movement will be somehow disturbed by the gravitational pull of this exoplanet. That wobbling will be watched very minutely by the astronomers, and they will predict the existence of exoplanet around a star. The bigger the planet, the bigger the gravitational effect it has on its star. Some planets like Earth make their stars only wobble a tiny bit. Bigger planets like Jupiter have a much stronger effect, so that the star's wobble can tell us if a star has planet, how many there are and how big they are. So all these things can be identified by knowing the star's wobble, how the movement of star is disturbed by the gravity of the planet orbiting around it. Then the planet causes the star to wobble around in its orbit, and as the planet moves to and fro, the light waves compress together and then stretch out, changing the color of the light we see from the star. So redshift, gravitational redshift concept is also used by the astronomer to prove the existence of exoplanet around a star. So when visible light wave stretches out, they make an object look more reddish. This change in color is called redshift, and scientists can use it to see if an object in the sky is moving towards us or farther away. Putting together that gravitational redshift and wobbling of the star, exoplanet will be confirmed. So the planet causes the star to wobble around in its orbit, and as the planet moves to and fro, the light waves compress together and then stretch out, changing the color of the light we see. So putting together, we will get the confirmation for the existence of exoplanet around a star. The radial velocity method was one of the first successful ways to find exoplanet, the method which I explained earlier, and continues to be one of the most productive methods. Often this method will be used to confirm planets found with other methods, an extra step that can prove existence for the planet. So radial velocity method is the prime and confirmatory method for the existence of exoplanet. The next method is transit. This method adapted the observation of shadow of the exoplanet or reduction in observed light of the star of the exoplanet. We know when the exoplanet moves in front of the star light will be partially eclipsed or fully eclipsed or 3/4 eclipsed based on the size of the planet. This concept is used in the explanation of solar eclipse, lunar eclipse. So that eclipse concept is used here to understand the existence of exoplanet around a star. When a planet passes directly between an observer and the star it orbits, it blocks some of the star's light. For a brief period of time, that star actually gets dimmer. So light curve is used how long the star's light is dimmer. So based on the light curve, the existence of exoplanet and size of the exoplanet and number of exoplanets existing around that star can be predicted by the astronomers. The small change in observed light from a star is enough for astronomers to confirm the existence of exoplanet. It's enough. A light curve is drawn between the light and the time, which explains the existence and size of the exoplanet. Bigger exoplanets blocks more light, hence the light curve will be deep in nature, and multiple curve in a single graph signifies the existence of many exoplanets with a single star. This transit method helped astronomers to explore the atmosphere of the planet. Atmosphere of the planet exploration can be done using the spectroscopic techniques. Using spectroscopic techniques, elements present in the examining object can be predicted. For example, if you are examining the atmosphere of a planet, if that atmosphere contains some elements like hydrogen, oxygen, nitrogen, like Earth's atmosphere, then particular absorption line will exist in the spectrum of the atmosphere of the planet. So the atmosphere of an exoplanet can be explored by this transit method. They found the existence of methane to water in various exoplanets using this transit method. This transit method has been spectacularly successful at finding new exoplanets. NASA's Kepler mission, which hunted for planets using the transit method from 2009 to 2013, found thousands of possible exoplanet discoveries and gave astronomers valuable information about the distribution of exoplanet in the galaxy. This Kepler's mission used this transit method for the existence of thousands of possible exoplanets. This is an artist rendering of NASA's deep telescope. Then the next thing is direct imaging, another technique used for the existence, used to predict the existence of exoplanet. Direct imaging, as I told earlier, directly photographing the exoplanet, but it's difficult because light coming from the star around which the exoplanet rotates will completely disturb the image of the exoplanet to be photographed. 49 planets were discovered by this method by the astronomers in the world. The major challenge in this method is blocking the light from the star of the exoplanet, because these lights will be reflected by the exoplanet based on the distance of existence of the exoplanet around that star and the amount of heat the exoplanet receives from the star. We know stars will produce light and heat by nuclear fusion reaction. The energies produced by nuclear fusion reaction are very high. So such energies will come out in the form of light and heat. When this light and heat are reflected by a planet very closer, then it's very difficult for an instrument or an object photographing, imaging the exoplanet or object. So if the exoplanet is far away from the star, then they can use some preventing method like preventing the light from the star and photographing the exoplanet. There are two main methods astronomers use to block the light of a star. One method is chronography. In this chronography, a device is used inside a telescope to block light from a star before it reaches the telescope's detector. In telescope, in any imaging device, the time the shutter is open decides the quality of the image. Amount of light received by the photographic plate present inside the imaging device also does matter. So in space, think about a telescope which carries an imaging device. This imaging device should block the light coming from a star. So the blocking technique is called as chronography before it reaches the telescope detector. Chronographs are built as internal and add-ons to telescopes and are now being used to directly image exoplanets from ground-based observatories. So many optical engineering concepts are used for this chronographs. Optical engineers are working hard, putting their effort, innovative ideas to build this chronograph to prevent the light entering into the telescope from the star around which the exoplanet is rotating. Exoplanet exists. Another method is to use a star shade, a device that's positioned to block light from a star before it even enters a telescope. So in this picture you can see a star shade. This is the star shade. The star shade can expand and open like an umbrella. So this umbrella like thing will prevent the light coming from the star, and the planet light alone can be allowed to the telescope, the image present in this telescope. So the first technique is chronograph. Chronograph is used a technique, optical technique used to reduce light entering into the telescope. This is another technique is star shade. The star shade is a device that's positioned to block light from a star before it even enters a telescope. For a space-based telescope looking for exoplanets, a star shade would be a separate spacecraft. So two spacecraft should be launched. The distance between the two spacecraft should be decided, then designed to position itself at just the right distance and angle to block starlight from the star astronomers were observing. So if you want to observe an exoplanet which is in some solar system, which is around a star, first you have to orient the star block towards the star around which the exoplanet is revolving. Then switch on the space telescope, then you will get the photograph of the exoplanet. So this is the direct imaging technique used by astronomers in astronomy to image the exoplanet. This direct image is still in its beginning stages as an exoplanet finding method, but there are high hopes that it will eventually be a key tool for finding and characterizing exoplanets. Future direct imaging instruments might be able to take photos of exoplanets that would allow us to identify atmospheric patterns, oceans and land masses in exoplanets. So direct imaging technique is a future technique, not a technique currently in use. The next technique is gravitational microlensing. We know light will undergo a gravitational shift. When light travels through a gravitational field, its path will bend, its path will shift. That's the physics concept we all know. The same concept is used in gravitational microlensing. The light from distant star is bent and focused by gravity as a planet passes by star and Earth. Sometimes gravity can bend and focus light like a lens in a magnifying glass or pair of glasses. We know optical lens, magnetic lens, here gravitational lensing, a wonderful concept which is used to image to find the exoplanet. When light from a planet passes through the gravity, and the gravitational field will focus the gravitational lines from the planet using a pair of glasses or magnifying glasses. Gravitational microlensing happens when a star or planet's gravity focuses the light of another more distant star in a way that makes it temporarily seem brighter. So 89 planets were discovered by this method. This gravitational microlensing technique concept has helped astronomers to discover 89 planets using this. To an astronomer, a lensing event looks like a distant star that gets gradually brighter over the space of a month or so, then fades away. If a planet happens to be lensed in the sense light from the planets are bent and focused, it looks like a brief blip of light that happens during this brightening and dimming process. So this brightening and dimming process will help astronomer to find the existence of exoplanet. But astronomers have to search different regions of the space for the existence of brightening and dimming process. Astronomers cannot predict when or where these lensing events, that is brightening and dimming process, will happen. So they have to watch large parts of the sky over a long period of time for this brightening and dimming process. When they record a star getting brighter and then dimming, in the pattern of lensing objects, they analyze the data to get information about the estimated size of the star. Sometimes free floating planets in space, ones that don't orbit a star, will cause quick microlensing events that astronomers will record. These events give us an idea of how common the so-called rogue planets are in the galaxy. The animation on the right show that kind of event looks like a telescope. The next technique is astrometry. So the orbit of a planet, exoplanet, can cause a star to wobble around in space in relation to nearby stars in the sky. So Doppler shifts are not the only way astronomers can find stars that are wobbling due to gravity of their planets. The wobble can also be visible as changes in the star's apparent position in the sky. In other words, scientists can actually detect the star's position wiggling around in space. So this astrometry technique is a method still amazingly hard to do, but people are using this astrometry technique to discover exoplanet. Stars wobble such a minute distance that's very difficult to accurately detect the wobble from planets, especially small ones the size of the Earth. Such minute wobbling of stars can be identified using this astrometry technique. In order to track the movement of these stars, scientists take a series of images of a star and some of the other stars that are near in that sky. So two stars are required to confirm the existence of exoplanet around a star. The star around which exoplanet is moving and the nearby star. So images of series of images of the stars should be taken. In each picture, they compare the distances between the reference stars and the star they are checking for exoplanet. If the target star has moved in relation to other stars, astronomers can analyze that movement for signs of exoplanet. Astrometry requires extremely precise optics and is especially hard to do from the Earth's surface, because our atmosphere distorts and bends light. So this is how the exoplanets are explored, discovered using the astrometry techniques. So to discover exoplanet, scientists are using 5 techniques. To summarize the concepts we have discussed so far, exoplanet is any planet beyond our solar system. In Milky Way galaxy alone, 3081 solar systems are present and 4158 confirmed exoplanets are there. So to find another planet like Earth, astronomers are focusing on the habitable zone around stars. Habitable zone temperature should not be too high and too low. There are 5 ways to discover an exoplanet: radial velocity, watching for wobble; transit method, watching for shadows; then direct imaging, taking pictures of exoplanets; then gravitational micro lensing, using the concept of bending of light rays in a gravity and focusing the light rays; then astrometry, minuscule movement of star and its neighboring star. So like that, exoplanet can be explored for life, extraterrestrial life in space. People are still exploring exoplanets for life. You can refer these websites to learn more about the exoplanet. Thank you.